Swayam Prabha. Digital India. Educated India.
Hello everyone. Now we will continue with the thermal protective textiles. So, now we can try to understand what are the physiological responses to the heat, which actually at higher heat how our body responds to the heat. So, in extreme heat condition there are different changes takes place in our body. Okay. So, understanding the body response to the heat is critical for designing effective protective textiles. So, we must understand what are the body requirement and what are the body changes, so that we can design our clothing. So, the body responses are that body gets stressed, heat stressed, body inability to cool down effectively. So, at extreme heat condition, so that heat stress situation we should we should try to prevent, and body in due to its physiological activity, it actually generates different types of cooling activity for to cool down the body core temperature. So, like your sweating and different types of that, like dehydration is also response, excessive fluid loss through the sweating in the extreme heat condition, and heat stroke, that is life threatening condition when our body core temperature increases. So, these are the different body physiological situation may occur, and during the extreme heat. So, we have threat of burn injury. So, let us try to understand what are the different types of burn injuries. It results when the temperature of the skin cells become high enough for the material enclosed by the cell wall to undergo physical changes. So, that is what the cell situation, skin cells situation, that it gets changed, cell walls. This process which occurs at temperature above 44 degrees Celsius. So, when the temperature of the environment is above 44 degrees Celsius, then the burn injury starts. The progression of burn injury is largely related to the time duration. So, above 44 degrees Celsius, if it is a fraction of second, then there may not be a burn injury, but depending on the time duration, that is important. So, only the temperature is not a matter, because if I touch a hot surface just for a fraction of time, then I may not get burn injury. But if for say a relatively lower temperature, say 50 degrees Celsius, some hot plate, if I touch for long time, so I may get burn injury. So, that is the time duration is very important. So, the burn injury often measured in terms of degree of burn. So, degree of skin burn. So, higher degree of burn, higher will be the severity. So, there are different degrees. So, first degree, second degree, third degree, and higher severity. So, burn depth is measured the severity. So, different severity. So, that is measured by the depth of the burn. First degree burn is most common type of burn, like sunburn and all these things. So, these are the very common types of burn, it takes place in the surface. So, outer layer. So, epidermis of the skin is affected in this type of burn, skin readiness and all this type of effects will be there. So, skin becomes red and there is no blister formation. So, that is the first degree of burn. It can be removed with the time, and second degree burn usually results in blister and accumulation of fluids, fluid gets accumulated. So, that is second degree of burn. Epidermal and dermal layers are affected and healing takes some weeks. So, first degree burn it takes maybe few hours, here it takes a few weeks time. The skin blister epidermis must regenerated. Okay. Onset to the degree of burn, energy on the bare skin is considered constant, but constant value equal to 1.2 calorie per centimeter square. So, this is per the IEEE standard. And third degree burn, which is very severe, it is a very serious burn, it results in damage of regenerative cells and affect basal layer. So, it goes in depth, and that is why that it damages the whatever cells are regenerative cells, that also get damaged. So, the skin cannot be automatically, that it cannot get recovered. Healing is not possible naturally. So, exposure to flame can rapidly exceed human tissue tolerance and cause second or third degree burn. So, in case of flame, the time duration may be less. Okay. For hot surface, maybe some time is required depending on the temperature. So, or type of heat flow. So, that burn degree of burn is it occurs. So, skin burns, the burn injuries are often measured in terms of degree of burn. So, you can see the first degree of burn. So, it skin gets reddishness. Okay. So, surface epidermal superficial burns. So, it gets recovered with time, maybe for after few hours. So, in second degree burn, it you can see that blister formations are there, it takes some time, maybe few weeks, and third degree burn it gets total, the skin is damaged. So, basic principle of thermal protections. So, now we will try to understand the protective textiles. What are the basic principles we should follow to design our clothing? So, protective textiles leverage various mechanisms to prevent the heat transfer and safeguard the wearer. First is the insulation. So, insulation, where we can generate the insulation in clothing that will actually prevent the conductive heat. So, trapping the air or using low thermal conductivity material to improve heat improve the thermal resistance. So, to stop the heat flow often through multi-layer fabric assemblies. So, multi-layer fabric assembly main advantage is that in between two layers there will be still air. So, this is the multi-layer. So, insulation we can create by trapping the air. So, we can create a fabric layer with a porous layer where air is entrapped. So, that will actually work as a insulator, or it will work as insulator, or if we use the multi layer clothing ensemble. So, in between layer there will be steel air. So, that will act as insulator. So, insulation is one way. Next is the heat reflection, particularly for radiative heat. Okay? The radiant heat gets reflected, maybe using the aluminized coating. So, utilization of high reflective surface, say aluminized coating, so to bounce the heat back away from the human body, where the chances of radiative heat is like the people working in front of the hot source, heat source like a furnace. So, there the protective clothing should be the reflective heat reflective way, that like your radiant heat reflective clothing layer should be there at the outside. Heat absorption and phase change. So, another approach is that the clothing, inside the clothing there will be phase change material, and here in that will absorb the heat, the phase change material. So, incorporation of phase change material that absorbs large amount of heat energy during the phase change, providing the temporary cooling effect. So, heat does not come inside, okay. It absorbs heat, okay, and then it acts as a heat blocker. And the fourth approach is that sacrificial layer. What is that? So, in sacrificial layer, like this is the clothing layer, and in outside there will be one coating which will act as sacrificial layer. So, the outer layer during the heat it will char, it will form char or degrade upon the heat exposure, and then that means it is absorbing the majority of heat and protecting, preventing the heat to enter inside and protecting the wearer, and at the same time this char will also act as the insulator. So, this is the principle. So, we should use one or more than one at a time depending on the application. So, first let us see the thermal protection by insulation. So, we can see that we have to create some insulation. So, we are adding some insulating layer, that means some entrapped air or some insulating material. We can see here our daily life example is the thermoflux. Thermal flux is that in the double layer in between there is a vacuum, okay. Still it is a vacuum flux. So, where through that it acts as a highly insulating material. So, conductive heat does not get transmitted through this. So, that means the hot or cool liquid it remains hot or cold. So, heat does not get transmitted through this. Similarly, we can create in our clothing, in clothing we cannot create a vacuum, but we can create the insulating layer by the incorporation of bulky porous material, porous fabric, where the highly insulating air is entrapped. So, we prevent the conductive heat to get transmitted. So, reduce heat transfer acts as a barrier by lowering the conduction, convection and radiation. Maintains the temperature gradient. So, trap still air or gases within the structure to slow down the heat flow. The material properties we can use here is a low conductivity material or porous material and high thickness. So, if we increase the thickness, so the conductivity will be keeping the mass is constant. So, if we increase the thickness, that means high porosity will be there. So, that will increase the thermal insulation. Even if we use the hollow fiber as a filler, in that case the steel air is entrapped in the inside the fiber also, that will act as an insulator. The applications are widely used for protective clothing, building envelopes, so the insulation of building we can use, spacecraft, fire barrier. So, different types of applications are there. In protective textile we use this insulation principle widely. Now, by reflection, heat reflection. So, you can see this type of clothing, reflective clothing is very commonly used for the places where high radiant heat conditions are there. The reflective surface, shiny or aluminized layer reflect radiant heat, reducing the heat absorption. So, heat gets reflected out. So, the wave gets reflected, it does not penetrate, and protective uses are very common for firefighter gear, foundry worker, space applications to shield from the extreme radiant heat. So, people in a space suit, so we will see this type of layers are there, because their extreme temperature is there, because the direct radiant heat exposure is there. So, to prevent the human, we used to use this type of protective gear. Now, thermal protection by heat absorption or phase change. Now, here is outer shell fabric. Okay. Now, this is the heat source, and here if you see, this is the phase change material layer. So, which absorbs heat. So, materials with high heat capacity absorbs and store thermal energy, delaying the heat transfer to the body. So, once someone enters, it absorbs heat and it stores heat in it, and it delays the heat transfer to the human body. So, by the time the firefighter will perform his completes his operation and will come out from the heat source. The PCM absorbs and absorbs it can absorb or it can release latent heat during melting and solidification. So, when it is getting melted, okay, it absorbs latent heat. That means, it absorbs latent heat from the cool body, that is from the body, and that is further it provides cooling or thermal buffering. So, once it this has actually heat absorber, it absorbs heat and at the same time it also cools down by taking the latent heat. And sacrificial layer is the outer layer which absorbs heat and degrade. So, controlled thermal degradation. So, textile outer layer, which is actually maybe some coating, okay. Outer layer undergoes charring or melting or sublimation that takes place and dissipating heat energy by delaying its transfer to the inner layer. So, during this process it actually delays the heat transfer. Formation of protective charge. So, after decomposition, this decomposed fibers generate a carbonaceous or foamed charred layer that acts as insulating barrier against the heat and flame. So, this is very important. So, here we can see this char, it acts as the insulator. Now, in textile application it is widely employed in flame retardant fabric, multi-layer protective clothing and coating where sacrificial fibers are burned. So, there it may be by the sacrificial layer, may be some coating or maybe some fibers, fiber blends, modacrylic, FR cotton, aramids, okay, enhance the thermal protection. So, fire protective clothing is actually designed in such a fashion, the outer layer sometimes deliberately we think it has got damaged. So, that char will additionally help in protection. Why do we need the specialized textiles? Because so limitations of some traditional textiles. So, normal textiles it has got limitation. So, what are the limitation? So, in normal textile like cotton, polyester, wool, that this ignites, melts or degrade quickly. So, we do not we cannot use polyester or wool solely independently for fire protective clothing due to their low heat resistance, due to their poor thermal stability, rapid loss of strength. So, at high temperature the fabric the fiber should retain its strength and integrity. Now, the advanced fibers are are replacing this traditional fiber. So, advanced high performance fabrics are actually enhanced thermal protection. So, initially it was a low thermal protection, then enhanced thermal protection like aramid, modacrylic, fire retardant treated fibers withstand ignition, resist melting and provide insulation. So, this type of advanced thermal protection is required and they are durable. It maintains strength for long, after long, even after long exposure of heat, dimensionally stable and they are comfortable in extreme thermal condition. So, that is why traditional clothing is not used for heat protection. So, we used to we have to go for the advanced fiber technology. So, what are the importance of thermal protective clothing? It protects firefighters from burn, radiant heat, flame, hot surface, molten metal, hot liquid, steam. So, any type of threat. So, this it protects the firefighter and it reduces the fatality, injury and property loss by enabling safe operation in extreme thermal condition. And at the same time this fabrics are designed so that it can release moisture vapor and maintain the comfortability. It fabric become the firefighter becomes comfortable and it is he is not heat stressed. So, that he can perform optimally. So, that is why the thermal protective clothings are required. So, high performance fire retardant fibers ensure durability, thermal insulation and sustained protective performance under varying hazard. So, we must use the high performance fiber. So, to perform effectively. So, one thing is that it is a high performance at high temperature, it should be comfortable during work, it should reduce the fatality and it should protect from the burn. Okay. So, all these requirements are there and our protective textile should perform all this. Now, before going to the latest technology, first let us try to understand the evolution of protective clothing. So, early iron worker or ancient medieval time used to heavy wool fiber or leather or thick fabric. So, that wool is actually by nature it is not flammable. Okay. So, that is why the thick fabrics are used and rely on bulk and weight. So, that in that time only protection was important. So, the comfort was not the main issues. So, people used to wear the thick fabric, compact fabric or leather or heavy wool fabric to protect themselves for basic skill. And then 19th century firefighter they adopt wool and treated cotton coats with oil and wax finish to limit the flame risk. Wax is one type of say phase change material. So, it actually it absorbs heat. And mid 20th century. So, in the different types of fibers are developed. So, in introduction of aluminized fabric for reflective heat and asbestos suit for radiant heat reflection. Okay. So, asbestos was used, but later it was discontinued due to the health hazard. But in 20th century these fabrics were used. Now, in modern era there are aramid fibers are developed. So, high performance fibers are used which we have already discussed, meta or para aramid, moderate acrylic fibers are used, carbon, PBI fibers. So, with multi layered system offering heat resistance, durability and wear comfort. So, in normal modern era we do not use clothing in a single layer, even if it is a high performance fiber like meta and para aramid, but we do not use a single layer, we use multi layered system, and each and every layer they have their own performance, own duty to perform. So, firefighter clothing, it protects from different types of threats. Okay. So, extreme heat is one issue, but chemical hazard may also take place along with the firefighter or biological hazard. So, the clothing should be such that extreme heat along with the chemical and biological hazard, one should protect us from this type of hazard, and we should also, it should not be the air permeability, water vapor permeability, mostly common characteristics, this should not be compensated, this compromised. Okay. So, air permeability, water vapor permeability should be such, air, water in vapor form, even in liquid form, it should get transferred through the clothing layer. And ultimately, if it is if we try to protect ourselves without considering the air and water vapor permeability, they ultimately causes the extreme sweat dehydration. So, you can see this type of situations may arise. So, now what are the fibers, modern fibers which are used for fire protective clothing? So, natural fibers are still in use. So, cotton fiber easy ignition, supports combustion, okay, but requires chemical flame retardant treatment. So, FR treated cotton is still in use. Okay. Wool naturally flame resistant due to high nitrogen and moisture content and charge in state of melting. So, wool fibers are still used in different types of heat protective clothing. Silk and jute, the limited thermal stability, potential improved with the fire FR treatment. So, if we treat the silk or wool with a fire treatment, fire protective treatment, okay, so fire resistant treatment, then we can use the silk wool also. And the limitations of this type of natural fibers are low inherent heat resistance and durability under extreme heat condition to the high performance fiber. So, this is comparatively it has the performance is lower, but still one can think of using this this type of fiber with at least with a lower thermal threat, and we can use as an inner layer. This type of fibers can be used as a one of the layers. Now, the synthetic polymer, polyester and nylons are normally not used for this firefighter clothing. The mechanical strength are strong, lightweight, durable. Okay. Melting hazard is that low softening point and soften and shrink, drip under the heat exposure. So, that is this is the main drawback. So, low softening point, okay, and it gets shrink. So, that is not required, that is not actually required in case of firefighter clothing, and it drips. So, that is why synthetic fiber like polyester, nylon is normally not used for fire protective clothing, and these are flammable, readily ignite and sustain burns. So, and FR treated fibers are there, requires flame resistant chemical FR resistant, but it is for not for the firefighter clothing, it does not get fire immediately, but it can melt. So, to develop any clothing protective textile, we must also know what are the fibers we should not consider. Now, coming to the high performance fiber, there are large number of high performance fibers are there, meta-aramid. So, Nomex is a DuPont's fiber. There are different types of meta-aramid fibers for used for firefighter clothing. Para-aramid is also used, it has got also higher strength. PBI fiber, PBO fibers are also used. Modacrylic is widely used for different fighter clothing. Carbon fibers are used for very high temperature fire protection. Basalt fiber is a natural resource that we can use this fiber for, and glass fibers for heat shield we can use. It is as a relatively cheaper fiber. Now, let us see the meta-aramid. The thermal characteristics of meta-aramid: low flammability and stop flame propagation. So, this is very commonly used nowadays. Better protection in most extreme environment. More durable than polyester blend or FR cotton. So, this is more durable. So, meta-aramid one can select. Good comfort characteristics. So, all the positive characteristics are there for to produce fire protective clothing. So, meta-aramid is a good choice for fire protective clothing. The main drawback of meta-aramid yarn, the drawback in intense heat, it gets shrink little bit. So, there will be little shrinkage in meta-aramid fiber and it can break. The solution here is that, so we can blend with the para-aramid fiber. So, that is 50-50 meta and para-aramid or 75-25 meta para-aramid we can use to get to reduce the shrinkage. So, para-aramid shrinkage is lesser than the meta-aramid. So, it reduces the shrinkage, and also para-aramid is stronger than the meta-aramid. So, we get ultimately high strength, better durability due to less shrinkage, improve mechanical properties and does not melt, but swell, and it becomes thicker and provide better protection. The fabric gets little bit swell at high temperature because the difference in the shrinkage characteristics. So, para-aramid shrinks less and meta-aramid shrinks little bit more. So, when we blend, it forms the fibers get buckled, the para-aramid gets buckled when the meta-aramid is shrinking. So, that creates the air pocket and which provide the better protection. Fabric gets thicker, and para-aramid, for example, Kevlar, there are different types of para-aramids commercially available. Excellent thermal stability, superior tensile strength. So, 2.5 times of the nylon fiber, and it has elasticity is good. better cut resistance. So, it is also used to in case of cut resistant clothing. So, it is high strength, does not melt as decomposition temperature of para-aramid is 500 to 550 degrees Celsius. So, that is a decomposition, it does not melt. So, we can use at high temperature application, and it is a chemically resistant. Okay. Now, PBI fiber, it is also used for the firefighter clothing. Decomposition temperature is 540 to 760 degrees Celsius, high heat resistance. Very high abrasion resistance. So, PBI fibers abrasion resistance is very, if we blend this PBI fiber with meta-aramid. So, abrasion resistance will be high. So, which is required for the firefighter clothing, insoluble in most of the solvents, and its density is low. So, it will become lighter, and glass transition temperature is very high. Okay. It is 440 degrees Celsius. So, that means for high temperature application we can use this PBI fiber. Now, PBI fiber, so commonly the Xylon is the trade name commercially available PBI fiber. So, tensile strength here, it is the highest of all textile material marketed on industrial scale. So, very good tensile strength, 37 centinewton per decitex, and degradation temperature is very high, and you can see the LOI is 68 LOI, and degradation temperature is 650 degrees Celsius, very high temperature resistant fiber, excellent creep resistance. So, it does not get creeped, and very good anti cutting performance. So, cut resistance clothing we can use also, and it shrinkage is very low. So, for all these characteristics, if we understand these characteristics, we can select the performance, and although these fibers are expensive fiber, so we can select depending on the application. Good abrasion resistance, and it is inert to most of the chemicals, wide range of chemicals. It does not get reacted with the or decomposed with different types of chemicals. Now, next fiber is a modacrylic. So, LOI value is 28 to 32%. So, inherently flame resistant and self extinguishing fiber, relatively high LOI value. Softening temperature is 220 to 230 degrees Celsius. So, it has got lower thermal stability. So, that modacrylic we can use accordingly the different types of application, and we can use in blend with the aramid fibers. It has a good chemical resistance, resistance to acid, weak alkalis and solvent. So, this is basically very important, different types of chemicals, if it is resistant. So, we can use the modacrylic accordingly, and it is density is low, 1.3 gram per cc, and excellent spinability and dyeability. So, mud acrylic is also used in case of high performance fabric, even different protective clothing we use mud acrylic. And carbon fiber. Carbon fiber is used also we can use for protective clothing. Along with the carbon fiber, due to its high strength, we can use in case of high strength application. In fire protective also, in some places we use the carbon fiber. It is a thermally stable, retains strength at very high temperature, more than 2000 degree Celsius in inert temperature. So, it can retain its temp, it does not get degraded. High strength to weight ratio. So, it is very strong and lightweight, okay, and strong and lightweight, ideal for protective composites. So, in composite the reinforcement we use carbon fiber very commonly. It has excellent chemical resistance to most of the acids, alkali and solvent. Main problem is that it is a brittle in nature. So, here if you see the carbon fiber stress strain curve, the elongation is very low. So, this type of brittle nature, high cost, restrict direct apparel use, commonly used for blend and composites. So, it is expensive fiber, for very specialized application we can use. In apparel we cannot use because it is a brittle in nature, but we can use in a blends if we need to enhance the characteristics. Application: foundry protection, aerospace, military, heat shield. So, different types of applications we can use, particularly in composite, high temperature resistant composite we can use this fiber, and also for where the strength is required, lightweight and high strength is required, there we can use the carbon fiber. Basalt fiber, it is basically natural resources. So, high thermal resistance, stable up to 700 degree Celsius, suitable for extreme heat environment. So, it is a chemically inert, actually resistant to acid, alkali and most corrosive agents. It is chemically stable, non-combustible in nature. So, naturally flame resistant, does not produce toxic fumes, that is important. So, most of the organic fibers, they actually after decomposition they release the toxic heat, toxic fume. So, basalt fiber can be used for some applications where high temperature situations, there we can use basalt fiber. Mechanical strength, high strength, durability, and it is comparable to glass fibers. So, fire blanket we can use, protective clothing, aerospace and defense heat shield. So, that many applications we can use basalt fiber due to this high thermal resistance. And glass fiber is very commonly used, non-combustible and does not burn and provide inherent heat, flame resistant. So, thermal stability is very high, can withstand this, it can withstand exposure up to 500 to 600 degrees without significant degradation. LOI value is very good. So, 35% LOI, chemical resistant, stable against most acid, alkali and solvent. Okay. So, it is for harsh environment we can use the glass fiber, and dimensionally stable. So, maintain structure strength even under extreme heat condition. So, all these different applications we can use where the high thermal stability is required and dimensional stability required. So, there we can use the glass fiber. So, if we see the comparative study of high performance fibers, so tenacity for PBO fiber you can see as compared to other fibers, you can see this PBO fiber tenacity is very good, okay, much higher than all the other fibers. And LOI value you can see ABBPI is 90 and here it is a 68. 68 is very good PBO fiber for high heat application, and specific gravity and modulus you can see, modulus is also, and your breaking elongation 3.5%, PBI fiber is having higher breaking elongation. Next is the incorporation of aerogel within the fabric structure. So, aerogel incorporation it is ultra low thermal conductivity. One of the best thermal insulator, limits heat transfer effectively within the structure. So, if in the fabric if we can incorporate aerogel. So, here in normal fabric what happened, it is if it is porous, that pore may get compressed. So, that thermal protection performance may change, but if we incorporate aerogel within the structure, it will give very high thermal insulation. Lightweight and porous, over 90% air filled structure. So, reduced garment weight while enhancing the comfort. High thermal stability, and it can withstand 600 to 650 degree Celsius depending on the type. And nanomaterial coatings are also available. So, to give the high thermal protection, so enhancing the thermal barrier. So, nanomaterial coating like silica or aluminum nanoparticle reduces the thermal conductivity of the fabrics to 0.03 to 0.05 watt per meter Kelvin. Actually, that if we coat the fabric with a silica or aluminum nanoparticle, it will increase the insulation. It will provide insulation against flame or radiant heat. So, that nanomaterial coating is nowadays we used to provide. Flame retardancy, nano coating can increase the thermal ignition by 30 to 35% and reduces flame spread rate. And in textiles, normal textile fabric like cotton, in cotton if we use the nano coating, so that can enhance the thermal protective performance. Durability and lightweight. So, thin coating less than 50 micron. So, that thin coating will help in increase the durability, maintain the flexibility, mobility, and it does not affect the moisture vapor transmission. This coating moisture vapor transmission and water transmission, heat transmission. So, that mobility, it will not affect the flexibility of the fabric, and comfort, that ergonomic comfort is not affected, suitable for PPE application. So, and another coating is a ceramic coating for fire protection. So, high thermal resistance. So, ceramic is it's highly thermal resistant. So, withstand extreme temperature without degradation. So, ceramic coating is also available. Barrier effect from protective layer that slow down the heat transfer and flame penetration. So, this acts as a barrier. Okay. So, ceramic coating is very useful, and it is stable for main oxidation and chemical. So, resistant to oxidation and corrosive environment under fire explosion. So, fire exposure in that case it helps in reducing the oxidation. So, the ceramic coating is also one alternative. So, use on textiles, composites and structural material for firefighter, aerospace and defense application. So, due to its high thermal resistance, it actually acts as barrier also, and it is stable in chemical, different types of chemical and oxidation. So, for that the ceramic coating is nowadays very popular. Then graphene for fiber protection, superior thermal barrier. Graphene lowers the conductivity of ceramic layer. So, and enhancing the insulation. So, ceramic layer has some conductivity, but if we actually use the graphene layer, so it will lower the conductivity, high thermal stability, it is stable at temperature around 1500 degree Celsius, and it resists flame penetration. Lightweight and flexible, thin coating like 10 to 50 micron at minimal weight, suitable for textile application. So, that means it becomes fabric becomes still flexible even after application of the graphene coating. It acts as a superior thermal barrier. So, advanced application applied in FR fabrics, aerospace heat shield, firefighter suit, protective composite. So, even after the textile fabric engineering, fiber engineering, yarn engineering or different types of fabric layer. So, we can use coatings like our you can see that ceramic coating, nanomaterial coating or graphene coating to enhance the fire protective characteristics. So, we will stop here. In next session we will start with the fabric structure and design for fire protective clothing. Till then, thank you.